Hello there. Today we're going to go through AQA's A-Level Maths Paper 2 from 2018, so that's the Pure and Mechanics paper. And I'm going to go through in this video the full paper, so that Section A, the Pure, and Section B, the Mechanics. Okay, let's start. So which of these statements is correct? Well, let's go through them. X equals 2 implies that x squared equals 4. Yes, it's that one. Okay, so if x is 2, x squared equals 4 is always true. So we don't need to check the other ones. But if we just did check, for example, the second one, x squared equals 4, that doesn't imply that x is 2 because x could be minus 2, for example. Okay, second one, find the coefficient of x squared in the expansion of 1 plus 2x to the power of 7. So the binomial expansion of that is 1 plus n x plus n minus 1 x squared over 2 factorial and so on. Okay, so we want this term here. So in this case, we've got n is 7, so we've got 7 times n minus 1 is 6, divided by 2 factorial. And instead of x, we've got 2x, so we've got 2x all squared. So if we multiply that all out, we've got 42 times 4x squared divided by 2. 42, so 4 over 2 is 2, 2 times 42 is 84. Question 3, find the total shaded area. Okay, well, if we want to find the area, just remember that any parts of the curve that go below the axis are going to give you a negative value for the area. So we need to deal with that appropriately. So this section first, the area is the integral from 0 to 4 of x cubed. So integrate x cubed, you're going to get x to the 4 over 4 from 0 to 4, which is 4 to the 4 over 4, which is 4 to the 3, which is 64. This part of the graph, we're going to get from minus 2 to 0. Of x cubed dx, but that's going to give us a negative value. So what we can do instead is we can switch around these limits, and that will give us a negative value. So that's going to give us, just do it over here, the same integral, x to the 4 over 4, same antiderivative, from 0 to minus 2 this time. So we've got minus 2 to the power of 4, so that's squared and squared again, so that's going to give 4 squared, in fact, over 4, which is 4. So the total area, 64 over 4 is 68. Question 4. A curve has equation y equals x squared minus 6x plus k, and we're also told it has two distinct positive roots. Okay, so what do we know? Well, first of all, it's a quadratic where the x squared coefficient a is positive, so it's going to be a U-shaped curve. We also know when x equals 0, if we just substitute that into the function, we get y equals k. So it crosses at k. And it has two distinct positive roots, so it's going to cross to the right of the y-axis at 2 points. So let's just do them here and here, and so the curve's going to look something like that, and so on. Right, find the range of possible values for k and justify your answer. Okay, so k is where it crosses the y-axis, it's the y-intercept. If that was greater, if we increased k, then what would happen is the curve would go up and up and up and up and up. Okay, and then eventually you'd get to a point where the graph wouldn't cross the axis anymore. So first thing we can say is that because there are two distinct roots, the discriminant must be greater than 0. So we can say that minus 6 squared minus 4 times 1 times k is greater than 0. 36 minus 4k is greater than 0. So k must be, well, k must be less than 9. if we rearrange that. Okay, but also if we go down too far, then if k was negative, then this would happen. Okay, so you've still got two roots, but one of them is now negative. Okay, and we're told that they are both positive roots. So we also don't want k to drop down below 0. So we've also got k is greater than 0. So if we write that as a compound inequality, we can say that k is greater than 0, but also less than 9. Okay, question 5, we've got to prove that 23 is a prime number. So how do we do that? We just got to try all the factors that could possibly go into this. Now, we're not going to go any higher than the square root of 23, which is about 4.8. The reason for that, for example, is if, let's say you did 24, we know that 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6, 6 times 4, and so on. Okay, so we know when we get past this point here, and square root of 24 is about the same number, slightly more than 4.8, we don't need to keep checking. We know it's just going to be repeated, but the opposite way around. So we don't need to go past the square root of the number when we're checking the values. So all we need to do is we need to check primes less than 4.8. And which prime numbers exist less than 4.8? Well, there's 2 and there's 3. So what we've got to check is do 2 or 3 go into 23? Well, first of all, 23 is odd, so therefore 2 is not a factor. And if we do 23 over 3, we find that that can't be simplified. Okay, we can't. We're going to get a decimal answer if we do that. So therefore 3 is not a factor either. Okay, so therefore 23 is prime. We haven't checked 4 because it's not prime, because 4 is just 2 times 2 and we've already checked 2. Right, question 6, finding coordinates of a stationary point, but well, it's this awkward function where we're going to have to use implicit differentiation. So if we differentiate implicitly, we've got something squared, so the 2 is going to come down to the front, and the power is going to go down by 1 to 1. But then we need to multiply by the derivative of the inner function. So because of the chain rule, x just differentiates to 1, y differentiates to y primed, minus 2 differentiates to 0. Then on the right hand side, we're going to have to use the chain rule again. So e to the y differentiates to e to the y multiplied by the derivative of y with respect to x, so y primed. And then the 1 differentiates to 0. Now we need to collect all the y prime terms on one side. Now, don't multiply everything out, but if you just split up this bracket, you can say that we've got 2x plus y minus 2 times y primed, and we'll move the 1 times all of this to the other side. So we've got minus 2x plus y minus 2. And then the e to the y term, we're going to move to the left-hand side. So we've got minus e to the y primed. Okay, now we can factor, now that we've isolated the y prime terms, we can factorize. So we've got 2x plus y minus 2, and then minus e to the y. And then we just need to divide by that. And we're looking for a stationary point, so we want this to be equal to 0. Okay, so we find that x plus y minus 2 is 0, which we could maybe rearrange as y equals 2 minus x. But that doesn't tell us a point. So what we need to do is, if we substitute that back into the original function now, what do we get? Well, because x plus y minus 2 is 0, the left-hand side is 0. And on the right-hand side, we're going to get e to the power of y, which is 2 minus x, minus 1. So e to the 2 minus x equals 1. And we know e to the power of 0 is 1, so that tells us that 2 minus x is 0, so x is 2. And y is equal to 2 minus x, so 2 minus 2 is 0. Okay, so there we are. There's a stationary point at x is 0. The wrong way around. X is 2, y is 0. Right, question 7. We've got a function here. We're told its range that y is greater than or equal to e. So that tells us that the minimum value is e here. And we're not told what the function is, but we are told its gradient. So to find the function itself, we're going to have to integrate that. So y is going to be equal to the integral of x minus 1 e to the x. So integrating the derivative. How do we integrate this? Well, we can see we've got an algebraic function times an exponential, so it's a by parts. So we're going to choose u equals x minus 1 and dv equals e to the x. So differentiate the first one, x minus 1 differentiates to 1, and e to the x integrates to e to the x. So apply the formula, which is u times v minus the integral of v times du. So just e to the x. And we can integrate e to the x to get e to the x again. So we've got x minus 1 e to the x minus another e to the x, and then plus c. We can tidy that up a little bit. So we've got x minus 1 e to the x's, and then take away another one of those. So we've got x minus 2 e to the x's. Okay, but we need to find c, so how can we do that? Well, let's use this point. I know the y value of that point. What's the x value of it? Well, at that point, the derivative is 0. So I know that dy by dx equals 0. And dy by dx was x minus 1 e to the x. So that tells me that x must be equal to 1 then at that point. So I've got a point on the curve now. X is 1, y equals e, and I can substitute that back in to find c. So e equals 1 minus 2 times e to the 1 plus c. So e equals, what have we got here, minus e plus c, so therefore c is 2e. So if I put that all back together, I get y equals x minus 2 e to the x plus 2e. Question 8. Determine a sequence of transformations which maps y equals sine x onto y equals root 3 sine x minus 3 cos x plus 4. Okay, we've got a function here that involves sine plus cosine. So this is where we need to write that as r times sine x plus alpha. Okay, whenever you've got multiples of sine and cosine, a linear combination of sine and cosine, you have to rewrite it. And there are different ways to rewrite it. You can write it in terms of sine or cosine, or in a plus or a minus alpha. But in this case, because we're comparing it with sine, sine is the sensible choice. So on the right hand side, if we use the compound angle formula, we know that this can be written as sine x cos alpha plus sine alpha cos x. And then we compare coefficients on each side. So if I compare the sine x terms on both sides, I've got root 3 on the left, and on the right I've got r cos alpha. If I compare the cosine terms, the cosine x terms on each side, I've got minus 3 on the left, and on the right I've got r sine alpha. So putting all that together, if we square and add these, we get that r squared is equal to root 3 squared plus minus 3 squared. So r is equal to the square root of 3 plus 9, which is root 12, which is 2 root 3. Okay, you may have just remembered that was the formula. Because what we've used here when we squared and added is we've also used sine squared plus cos squared is 1. To find alpha, we divide one equation by the other. So if we divide the second one by the first, we get the r's cancel out and we get sine over cosine, which is tangent. So tan alpha is equal to minus 3 over root 3, which is minus root 3. And this gives alpha equals minus 60 degrees. Now what we just need to check here before we go further is, are we in the right quadrant with that angle? Okay, so minus 60 would be down here. I'm just going to draw a cast diagram. So the cast diagram tells us which of the trig functions are positive in each quadrant, from 0 to 90 to 1 and so on. So if we go back to this bit here, this tells us the second part. We know r is always a positive number. Okay, so this tells us that sine is negative, okay, because it's negative 3, and the cosine is root 3 over r, so that's a positive number. So we're in the region where cosine is positive and sine is negative, so that is the fourth quadrant here. So we are on the right one. So minus 60 is fine. If you want to, you can add 360 onto that and express the answer as 300 degrees, but it doesn't really make a difference. So if we put that all back together then, so we're going to get y is equal to, so from here, so the first two terms now, we said that was r sine x plus alpha. So r was 2 root 3, alpha was minus 60, and then we've also got this plus 4. And now it's just a case of reading off that and seeing what all these different bits do. Okay, so what does the multiplicative factor in front of the sine do? Well, that's a vertical stretch. So it's stretching the y direction by a factor of 2 root 3. What does the minus 60 do? Okay, the minus 60 shifts the curve right by 60 degrees. So rather than sine starting at 0 and going up from there, it starts at 60 degrees and goes up from there. And what does the 4 do? So if we add on a 4 at the end, then that's a vertical shift up by 4 units. Okay, so 8b part 1, we need to show that the least value of this function, so 1 over the thing we've just been dealing with, has this value. Well, let's just draw this graph. So we had, when we put in a different form, we had 2 root 3s times sine of all the rest. Okay. Now, what does this represent? This represents the amplitude of the oscillations. And everything is being shifted up by 4. Now, 2 root 3, how big are those oscillations then? That's roughly about 3.5. But everything is being shifted up by 4. So everything is going to be above the x-axis. So it's going to look something like this. Okay, so there's some value here, and this is oscillating by about 3.5, and then above and below some value, which is 4. And we need to find basically these values. So the least value of this function must be where this bit is the greatest. So we're looking for the peak. So what's the value of the peak? So we've got 1 divided by 4 plus the amplitude, 4 plus 2 root 3. But that's not it. That's not what we're given. So how do I get to there? Well, I've just got to rationalize that. So how do I rationalize? I multiply numerator and denominator by the conjugate. So it's the same binomial, but we just change the sign. So we've got that. So on the top, I've got 4 minus 2 root 3. And on the bottom, I use difference of 2 squares. So 4 squared is 16. And 2 root 3 squared, well, I know that was 12 from what I did in the previous question. So I've got 4 minus 2 root 3 over 4. And if I divide top and bottom by 2, I get what I'm looking for. Right, find the greatest value of this function. Well, it's going to be the equilibrium position 4 minus the amplitude, minus 4 2 root 3. And to rationalize that, I'm going to multiply top and bottom by 4 plus 2 root 3. Now, I don't need to go through the whole thing again. Obviously, hopefully you can see what's going to happen. All that's going to change is the sign. So I'm going to have 2 plus root 3 over 2. Right, question 9. A market trader, notice that his daily sales depends on the number of hours and the total sales since the shop opened. And they say that the rate of sales is directly proportional to this. So rate of sales, that's the rate at which the sales change over time. So that's the derivative, dx by dt. It's directly proportional. So that means it's equal to a constant times the expression given. So let's call the constant lambda. And we're also told that after 2 hours, so t equals 2, the rate of sales, dx by dt, is 72. And the total sales, x, is 336. So we need to show this expression. So also we just substitute all these values into this equation. So we've got 72 is equal to lambda times 8 minus 2 over 336. So lambda is equal to 72 times 336 divided by 8 minus 2, which is 6. Now if we put all that together, we get a value for lambda of 4032. So dx by dt is equal to 4032, 8 minus t over x. And then if we just move the x across to the left-hand side, we get the expression that we needed. Okay. 9b, hence show that this is true. So when we rearranged it in the previous part, that was so we could use the separation of variables. So if we move the dt to the right, so we've got x dx is equal to, what did we have? 4032, 8 minus t, and we're moving the dt to the right and then integrating both sides. So on the left, I've got x squared over 2. On the right, I've got 4032, and then integrate this bit. So I don't need to integrate the 4032, that's just a constant. I'm going to get 8t minus t squared over 2. And then plus c. But I also knew from the first part, from the boundary condition, I had x equals 336 when t was equal to 2. So if I substitute those in, on the left I get 56448, and on the right I get 4032 times, so 8 times 2 is 16, minus 2 is 14, plus c, and if you work that out you find c is 0. So in other words, I've got x squared over 2 is equal to 4032, 8t minus t squared over 2. And if I just move the 2 across and bring it inside the bracket, I've got x squared is equal to 4032. Oh, and take one of these t's outside as well as a factor. 16 minus t, which is what I'm after. Part C, the stall opens at 9:30. The trader closes the stall when the rate of sales falls below £24 per hour. Using the results from the previous two parts, calculate the earliest time that the trader can shut the stall. Okay, so we're constrained by this. The dx by dt, we're looking for when is that less than 24? Well, we had an expression for that, dx by dt. Dx by dt was, from the first part, 4032 times 8 minus t over x. So if we multiply the x across, we have that, and then divide by 24. So we end up with that inequality. Now, if we square both sides, we get this, and the reason for squaring both sides is that in part B we had an expression for x squared that we can substitute in. So we end up with 168 8 minus t. Well, actually, let's multiply that out. 168 times 8 is 1344 minus 168t. So that was all squared. That's less than x squared, which from part B was 4032t times 16 minus t. Okay, if we do that on our calculators now, we get this horrible expression. And I'm sure somebody will tell me somewhere in the comments that I've probably missed something off here. I've probably got one of these digits wrong, but you get the idea. Hopefully I've done it right. So we get that, and then move all the terms to the same side of the equation. We get 32,256t squared minus 516096t plus 1,806,336 is less than 0. Okay, so we're going to have some graph that looks like this, and what we're looking for is the smallest value. So we're going to use the quadratic formula. So we've got minus b, so 516096, plus or minus. But I'm going to take the minus one because I want the smaller value. Okay, so I'm going to just take that one, divided by, because remember, we're looking for the earliest time that the trader closes. So that's why we want the first value. 516096 squared minus 4 times that times that, and then divided by 2 times a. And if you put that all together, you should get about 5.17 hours. Okay, now we're still not done yet. So 0.17 of an hour, if we multiply that by 60 minutes in an hour, we find that about 10.2 minutes. So 5.17 hours is the same as 5 hours and 10 minutes, roughly. So if the store opens at 9:30, then it shuts at 5 hours later is 14, and then another 10 minutes, 40. So 20 to 3, early finish, go home, great. Right, part 2, explained by the model used by the trader is not valid at 9:30. Well, it goes back to this derivative that we had right at the start. Okay, at opening, there won't be any sales yet, so x is equal to 0, and division by 0, that's what we'd have for the derivative. Division by 0 is not defined. Okay, so we can't use it there. Right, that's section A done. We're on the mechanics now. So a garden snail moves in a straight line from rest to 1.28 centimeters per second with a constant acceleration in 1.8 seconds. Find the acceleration of the snail. Okay, Suvat A equals V minus U over T. It's starting, it reaches a speed of 1.28 centimeters, so that's times 10 to the minus 2 meters per second. It's starting off at rest, 0, and it's taken 1.8 seconds. So if you put that all together, you find that answer there is the correct one. Second one, we've got a uniform rod which is supported at its center, so we don't need to worry about the weight of the rod because that has no moment. And we've got a mass of 4 kilograms to the left of the pivot, which will lead to a anti-clockwise moment, and this one will have a clockwise moment. So balance the moments. We've got 4 times g times 0.6 is equal to 1.5 times g times x. So x is equal to, cancel the g's out, 4 times 0.6 over 1.5. That gives an answer of 1.6. Right, question 12. We've got a velocity time graph. Find the maximum magnitude of the acceleration. Okay, if it's a maximum, we want the steepest part of the graph. Okay, which is between 12 and 13 seconds. You should just be able to see that by eye. So the acceleration there, so same again, v minus u. So the final velocity is minus 4. The initial velocity is 0. Divided by the time taken between 12 and 13, well, that's 1 second. So we get minus 4 meters per second squared. But the question asks for the magnitude of the acceleration. So all we should say is that the magnitude of the acceleration is just 4. And this was only a 1 mark question, so if you left it as minus 4, you wouldn't get any marks at all. Don't do half marks. Right, 12b. The object is at its starting position at times 0, t1 and t2. Okay, find t1 and t2. So that means that the total displacement must be 0 there, and then it must be 0 again when it gets to here. So that's what we're looking for. So we need to work out areas under the graph. Right, let's look at this first 5 seconds. So that in the first 5 seconds, the object is just moving away. So the area under that curve, let's write it up here. So the first 5 seconds, we've got a half of 2 times 4, so just the area of that triangle, and then up to 4 seconds, and then a half of 2 times 1 for the 5th second. So put all that together, 4 plus 1 is 5. So in the first 5 seconds, they've moved 5 meters in one direction, and then they've come to a stop. And then they're going to start moving back again in the other direction. So what we've got to find is how far along here do we go so that the area adds up to 5. Well, first of all, let's take off this triangle. So this triangle has an area of half times 2. So height times the base, 1. So that's 1 meter gone in the other direction. So we need 4 more meters traveled. So we're moving at 2 meters per second. So it must be another 2 seconds. And obviously you can see that has an area of 4. So that we've traveled 5 meters in the other direction. So t1 is equal to 8 seconds. Okay, so at that point, we're back to s equals 0. So now we're going to count from there. From 8 to 12 seconds, how much further do we go? I'll change colour here. How much further do we go in that other direction? So I've got, first of all, this rectangle. So that's going to be 2 times 3 seconds. So that's 6 meters. And then plus a half of 2 times 1, which is 1. So all of this is 7 meters. So now, after 12 seconds, I start to move in the other direction again. So how long has to pass before I've traveled 7 meters again? Okay, well, let's work out this triangle first. So that's a half of 4 times 1. So that's 2 meters traveled. So then how much further along here do I have to go? So I want to find 4 times some time t has got to be equal to 5 meters. Okay, remember we had 7 meters the other way. This first triangle has added up to 2 meters, so I need 5 more meters. So 4 times some time here equals 5, so that's 1.25 seconds. So 1.25 seconds after 13 seconds. So T2 is 14.25 seconds. Okay, hopefully that was clear enough. Hard to explain that question clearly. It's a bit of an awkward one. But they're the times. Right, on to question 13. A boy attempts to move a wooden crate of mass 20 kilograms along horizontal ground. The coefficient of friction between the crate and the ground is 0.85. The boy applies a horizontal force. Show that it's stationary. Okay, so let's look at the picture. We've got a crate. The boy is applying 150 newtons to it. The mass of the crate is 20 kilograms, so it has a weight of 20 g. So the normal force acting up is 20 g. And therefore the friction force, if it was to move, would be 0.85 times 20 g. So let's just work out the friction force, and that's the friction force that the boy has to overcome for the crate to start moving. So 0.85 times 20 g is equal to 167 newtons. And 150 newtons is less than 167, so the force forward is less than required to overcome the force backwards, so therefore no movement, stationary. Okay, part B, the boy uses a handle instead to pull the crate forward, so he's pulling up. Now, at first sight, this seems a bit counterintuitive because you might think, well, he's applying the same force, it's still 150 newtons, and he's pulling it up, so the horizontal component must be even less than before, so how can he possibly get it to move? But because he's pulling it at an angle, he's also applying a force up, so the normal force is less than it is before, and therefore the frictional force to overcome is less than before. Okay, so let's draw a free body diagram here. So we've got the same weight as before, 20 g. We've got some normal force, which we don't know. To the right, we've got 150 cos 15. Vertically, we've got 150 sine 15. And then this frictional force is 0.85 times n. Okay, so if we solve it vertically, first of all, we can say that n plus 150 sine 15 must be equal to the 20 g acting down. So n is 20 g minus 150 sine 15, and that works out at about 157.4 newtons. So horizontally then, let's just think about the forces. So we've got to the right, we've got 150 cos 15, and then to the left we've got 0.85 times the normal force, which was 157.4. And if you work that out, you get about 11 newtons. So therefore, there is a positive resultant force to the right. So the crate does move this time. Okay, if this was less than 0, we'd be in the same situation as before, but because it's positive, it means that there's going to be movement to the right. So the boy's force is greater than the frictional force. Okay, question 14 now is to do with position vectors. So we're given the position vectors of 4 vertices of a quadrilateral. First of all, write down the vector AB. So if we've got the origin here, and here's A and here's B, and that's OA and that's OB, then AB, to get from A to B, we have to go from A to O and then from O to B. But AO is just the negative of OA. So it's, in other words, it's just OB minus OA. So minus 1 minus 3 is minus 4. 2 minus 5 is minus 3, and 7 minus 1 is 6. Right, part B, show that ABCD is a parallelogram, not a rhombus. Okay, so let's just remind ourselves what these mean. So a parallelogram, you've got 2 pairs of parallel sides. So what we'd want to show here is that AB would be parallel to CD, and that that BC would be parallel to DA. Okay, that's what we'll be trying to show. But a rhombus has the additional rule that all the sides are equal. So we need to show that the sides are parallel, the opposite sides are parallel, but the sides are not equal. So what we're going to do is we're just going to work out the other. So we've found AB. We're going to work out the vectors from the other vertices to each other. So A to B was that. So B to C, and all we have to do is we have to just do it in the same way. So OC minus OB. So that's going to give us 1, 5 minus 1. C to D is OD minus DC, which is 4, 3, and minus 6. And D to A is OA minus OD, which is minus 1, minus 5, and 1. Okay, and you can hopefully easily see by just looking at these 4 vectors that we found that AB is just equal to minus CD. Okay, so they're parallel, they're the same, and they're the same length, just obviously in the opposite direction because we're going A to B to C, we're going round like that. So we've found CD, it's the same length but in the opposite direction to A and B. That's what we expect. And we can also see, if we look at BC and DA, that BC is just minus DA. Okay, so those facts there tell us that it's a parallelogram. The opposite sides are equal length and parallel with each other. Right, now what we just need to do is check the lengths of some of these sides. So if we look at the length of AB, for example, that's just going to be square root of 4 squared plus 3 squared plus 6 squared. So 16 plus 9 is 25, plus 36 is 61. What about BC then? We don't need to check CD because obviously that'll be the same length, but if we check BC, so that's going to be square root of 1 squared plus 5 squared plus 1 squared, which is root 27. Okay, so not same length, so therefore not a rhombus. Right, question 15. A driver is road testing 2 minibuses A and B for a taxi company. The performance of each minibus along a straight track is compared. A flag drops to indicate the start of the test, and each minibus starts from rest. The acceleration is modelled as a function of time after the flag is dropped. So first of all, find the time taken for A to travel 100 meters. Right, if we're given the acceleration, we want to find S. First of all, we know that the speed is equal to the integral of the acceleration. So we're going to integrate 0.138 t squared, which will give us 0.138 t cubed over 3 plus c. But we also know that it's starting from rest, so we know that v is 0 when t is 0. And that gives us c is 0. So we get v is equal to, in 0.138 over 3 is 0.046. So we get that for v. Now, if we integrate that again, because the distance is speed times time, so if we integrate that again, then we get 0.046 t to the 4 over 4, which is 0.0115 t to the 4. And plus c again, but we also know that s is 0 when t is 0. Okay, obviously if we're measuring the distance, we would have distance 0 when we start the timer. So we can just say that s is equal to that. So the question is, how long does it take to reach 100 meters? So we just need to solve s equals 100. So we've got that, so therefore t is equal to the fourth root of 100 divided by 0.0115, and that comes to 9.657 seconds to 4 significant figures which were asked for. B. The company decides to buy the minibus which travels 100 meters in the shortest time. Determine which minibus should be bought. So let's look at B now. So in the same sort of way, so we're going to integrate twice the acceleration, and for B, the acceleration was 0.024 t cubed. So if we integrate that once, we're going to get 0.024 t to the 4 over 4. And if we integrate that again, we're going to get t to the 5, and then the 5 on the bottom. So 5 times 4 is 20 on the bottom. Okay, so we'll just say it's that. If we divide 24 over 2 is 12, so we'll get 0.0012 t to the 5. I haven't worried about the plus c because it's going to be the same as it was last time, the plus c's. So I get that. And therefore this time, to find the time to do 100 meters, we're going to have the fifth root of 100 over 0.0012. And that comes out to be about 9.642 seconds. Okay, so we should buy minibus B. That's our conclusion because that's faster. I mean, it's only really a hundredth of a second faster over 100 meters, so they must really want those fares. 15c. The models assume that both minibuses start moving immediately when t is 0. In light of this, explain why the company may in reality make the wrong decision. Well, there's a couple of things to think about here. Okay, so the driver is putting their foot down, and we're only talking about a hundredth of a second, so we haven't considered the reactions of the driver to the flag being dropped. Okay, human reaction times, you're talking about maybe a 0.1, 0.2 of a second, so that's going to make a big difference. I suppose another possibility is when they've floored it, getting a bit of wheel spin. Okay, so maybe it's not started to accelerate straight away because the wheels are spinning. Yeah, a couple of reasons I suppose you could consider there. Right, question 16. The particle is projected with an initial speed u at an angle 35 degrees above the horizontal. It lands at 0.10 meters vertically before its starting position, and it takes 1.5 seconds to reach its highest point. This is sort of a very classic mechanics problem with projectiles. So it's going up like this, it's arcing through this parabola, and then it's ending up 10 meters below where it started. And we know at the top of its flight that takes 1.5 seconds, and this angle here is 35 degrees. So find u first of all. Well, let's just look vertically. So we'll take upwards as positive, and we know at the top of its flight its vertical component is 0. So we can use this. So we can say that 0 is equal to u sine 35 minus 9.81, so acceleration is in the opposite direction down, times t. So t is t is 1.5. So therefore u, which we're looking for, is 9.81 times 1.5 divided by sine 35, and that comes out to be 25.7 meters per second. Part B, find the total time that the particle is in flight then. So if we use s equals ut plus a half at squared, and again we'll go upwards. We're looking at the vertical component upwards. So it drops down minus 10 from where it starts. So it's 10 lower, 10 in the opposite, in the down direction. U was in the vertical direction, 25.7 times sine 35. And then t is what we're looking for. And then minus a half of 9.81 times t squared. So if we move everything to the left, half of 9.81 is 4.905. So we've got that. Minus 25.7 times sine 35 comes out to be 14.7. And then minus 10. So we've got this quadratic to solve. And obviously a quadratic is going to give us two values. Now, if I just annotate this diagram a little bit more, well, it's telling us the time when it's at that displacement of minus 10. So if you think about it, if we went back in time, there should be a negative time here where that was the case. But we're looking for the positive one. So when we use the quadratic formula, I'm just going to pick out the positive square root this time. Okay, the negative one, if we work it out as well, it's just going to give us a negative answer, and that doesn't mean anything here. So I've got 14.7, so that's minus b, and then just plus, like I've just said. 14.7 squared, and then minus 4 times a times c, and then divided by 2a, so that's just 9.81 again. And if we put that all together, we get 3.57 seconds. Okay, last question now. So we've got some golf buggy, it looks like, pulling a roller skater, and we're told some information here that the mass of the buggy and driver is 410 kilograms, the driving force is 300 newtons, and there's a total resistance force of 140 on the buggy, and a resistance force of R on the roller skater, who is 72 kilograms. And the whole system is accelerating at 0.2 meters per second squared. Find R. Right, for this first part, we're just going to look at the whole system together. So we've got, I'll just do that circle to represent the whole object. So forwards, I've got 300 newtons driving it forward. Yeah, so in reverse, we've got 140 newtons from the buggy and then we've also got a resistance R on the roller skater. So we're just going to use Newton's second law. So the sum of the forces is mass times acceleration. So we've got 300 to the right minus 140 minus R is equal to the total mass. So that's 410 plus 72 multiplied by the acceleration, 0.2. So we get that R is equal to 300 minus 140 minus 482 times 0.2. And if you calculate all that, you get 63.6 newtons. Part 2, find the tension in the rope. Okay, so if I just look at the forces on the roller skater, for example, like you could just look at the forces on the buggy as well. There's two ways to do it. But if I just look at the roller skater, I've got two forces, 63.6 there, and then to the right, the other force acting on them is the tension. So I've got, if I'm looking at forces to the right, I've got T minus 63.6 is equal to the mass, but this is just the mass of the roller skate I'm interested in now, times their acceleration. So T is equal to 63.6 plus 72 times 0.2, and that comes out to be 78 newtons. And then part B, state a necessary assumption that you have made. Well, there's a few things about that rope that you could say it's got no mass or it's inextensible. So if it's inextensible, it means that all of that force is going into pulling the roller skater rather than that force going into stretching the cable. Part C, the roller skater then releases the rope at point A at a speed of 6 meters per second. She continues to move forward with the same resistive force. The driver notices a change in motion and brings the buggy to rest at a distance 20 meters from where the roller skater left it. Determine whether the roller skater will stop before reaching the stationary buggy. Okay, well, let's work out first of all the acceleration of the roller skater. So we've got the force acting on them is just the resistive force, minus 63.6 against them, and divided by their mass. So this is just F over m. So we get minus 0.883. And it must be negative because it's a decelerating force. A deceleration, I should say. So minus 0.883. So then if we use v squared equals u squared plus 2as, we've got that the final speed is 0. The initial speed, well, let's rearrange this first. So s is equal to v squared minus u squared over 2a. So we've got 0 minus 6 squared divided by 2 times minus 0.883. Okay, work that out. You get 20.4 meters, which is greater than 20 meters. So therefore, skater doesn't stop in time. So they smash into the back of the buggy, comically like sung off Jackass. Okay, and then 17C part 2, last question. Explain the change in motion that the driver noticed. Okay, well, if once they've let go of the rope, there's a loss of tension. So therefore, the resultant force forward is greater. So what does the driver actually notice? So therefore, they experience a greater acceleration. Okay. And that's the end of the paper. So if you like that, please like the video and subscribe to my channel. There are lots of other videos available. And if you're interested in any one-to-one support or tuition for maths or physics as well, please visit my website www.physicsmathstuition.com. Bye for now.